presentation.
I think you are.
Yeah, now you can hear me?
Yes, now.
Okay,
now
and you can see that?
Yes, we can.
Okay.
Yeah.
Perfect. This isn't even the first slide. Okay, so my project for the term was called the Coalition for Reason. So I make a case for establishing scientific literacy promotion, a transhumanist goal, and then I'm going to provide you with some ideas of how we can actually accomplish this goal beyond formal education settings. So to refresh your memory, what is transhumanism? It basically, I'm going to use a very broad definition on purpose. Anything that kind of takes the human beyond. So that's where the trans part comes. So you could also say that it's for the promotion of welfare through science and rationality. Oh, and you're welcome to interrupt me if you have any like questions or comments. I'm happy to be casual with it. So when we're thinking about what transhumanism is, it's a very broad field, right? If we're talking about using science to better the world, we can think of so many different things. And so I've included, artificial intelligence, different forms of body modification, space exploration, you name it, there's probably some way to make it future thinking. And so as a community, transhumanists are generally very progress oriented. So both, social and scientific progress are causes for concern and of interest to transhumanists. And so who are transhumanists? I would say that for the most part, they are academics. And when I say academics, I don't necessarily mean someone who is, formally part of the academy. I more mean someone who maybe has a university background, someone who is familiar with like technical writing, that kind of stuff. So that includes scientists. Natasha Vitamore is the leader of like the Humanity Plus organization, and she's really big in the cryopreservation community. Entrepreneurs like Elon Musk, who's working on that Neuralink and SpaceX. I'm not sure if he'd call himself a transhumanist, but his projects definitely align with the goal. And we also have a lot of philosophers in transhumanism. Donna Haraway is my example here. She wrote a cyborg manifesto talking about feminism and transhumanism and kind of her vision for that. And so if I'd like to impress upon you one thing with this slide, it's that while it's meant to be for the general population, a lot of the transhumanist discourse remains kind of in the ivory tower, if you will. And kind of continuing with that, the ways that transhumanists, conduct this discourse is fairly professional and formal still. They will share their scientific findings through academic literature, they'll attend conferences, they'll have presentations, and then they'll also have, exclusive events. So I got myself on the Humanity Plus mailing list, and they have like a weekly salon. Like if you think back to the Enlightenment times, they have like these meetings where they only invite people on their mailing list to talk about these like highfalutin ideas. And that's great, but a lot of this is inaccessible to the average person. If I were to pick up academic literature from any other discipline, I can't really understand it. I can't get a pass to a presentation that I don't know about, or I can't afford to take a whole day off work to go to a conference. And then if you don't even know about these organizations, how are you going to, join their special events? Sorry. So the other thing I would really like to impress upon you is that transhumanism, in my opinion, is inherently political. And so we can think of that in terms of both, the technologies that transhumanists are making and, hoping to make, but also just the position that they're given in society. So they have a lot of social influence potentially, and they can exert a lot of physical power. So yeah, you you can see my Neil deGrasse Tyson here. Scientists, academics are, held to a certain standard in our society. Like we trust their opinion, we consider them experts. Science can also be revolutionary, right? You think about how much has changed since we got the internet. Like our whole society has completely changed. And then there's also potentially harmful technologies, making bioterrorist threats and doing all these different things with weapons. Like it's cause for concern, or at least, paying attention. So I think that we need systems of accountability to make sure that the transhumanist project remains in the best interest of the people they're trying to serve. If our goal is to really improve humanity, we need to make sure we know what humanity wants improved, and making sure that the way we're going about it aligns with the things humanity would want. And so instead of looking at all the different organizations and trying to kind of understand their vision for transhumanism, I chose to go more political route, to think about who should have power, how power should be, executed, in trying to kind of come up with this accountability system. And so if you look at this, there are democratic transhumanists. They're kind of what you would think of in, modern democracy, kind of like the Democratic Party of the United States. There are libertarians who are very hands-off, limited government. And then there are anarchists, which comes across as a not great word to most people, but it is more like communism, but without a leader. So it's very collectivistic. And so when we're trying to think about these systems of accountability that we could have, there's no consensus in terms of like if there should be government doing that, if we should let, capitalism kind of let that run out. It's hard to really say. But one thing that each of these perspectives and transhumanists as a whole agree upon is that democracy should be, maintained and upheld, and we should utilize democratic processes to help inform these decisions. And so thinking about democracy, I can go here. So my proposition is that we need to work on scientific literacy to ensure that democracy can function properly in the future. A lot of transhumanist thought right now, if they promote scientific literacy, it's more focused on, improving access to traditional forms of education, scholarships, free education, maybe making, like free access to academic literature. But for people to actually participate in the democratic process, we need to make sure that they're developing a certain skill set. And so this skill set includes, understanding how to do like a risk analysis when it comes to different scientific technologies, being able to critically engage with science, being able to understand, the implications of certain things. And while there is a certain level of, just purely scientific knowledge that you need, the skills that you can acquire are much more important because they can help you further, if you don't know something, but you know how to find out something, you can use those skills. And so when we're thinking about the effects that scientific literacy can have in the democratic process, we can think of micro social benefits and also macro social benefits. So on the micro level, that refers more to, the way that an individual person might exercise this scientific literacy and benefit from it in their personal life. On the macro end, it's more thinking society-wide, how scientific literacy could change culture, how it could impact politics. And so if we think of these benefits in terms of how they can help our accountability system that we're trying to, enforce and make more robust, the microsocial benefits, while we're still in, a capitalist system, while we're still, engaging with each other's products, we, on a micro level, decide which products we want to use, how we use them, we can get feedback. That is, in a way, an accountability measure. On the other hand, the macro social element is that, through voting and through, broader discussion in the community and through social change, people can exercise their scientific literacy, their scientific knowledge to help inform the Transhumanist project. So I propose the formation of something called the Coalition for Reason. If you're a fan of The Office, like I am, you'll recognize that this is Oscar. And he coined this term, which I am borrowing, when he was talking about how the rest of the office was just in pure chaos because everybody who was part of this coalition of reason was out of town that day. And so everything just descended. And so I propose a scientific literacy project. It would be an ever-evolving, collaborative, transhumanist project that seeks to make the future accessible to the general public by primarily promoting scientific literacy. So in imagining this project, I've come up with 3 general themes. The first is facilitating access to academic discourse. So this includes promoting textual engagement, giving people the tools they need to actually engage directly with academic literature, and then independent inquiry, giving people the tools they need to investigate things on their own, and then developing systems where there can be a two-way flow of communication between the public and transhumanists or the academic community, however you want to phrase it. And then my second theme is legitimizing novel forms of outreach. So this includes building infrastructure to communicate science in new ways. So historically, there's been a push for scientists to have their own blog or to collaborate with certain citizen science magazines. And while that's great, it's not bad, but it doesn't meet people where they already are. And to actually get the general public, you need to start doing that. And then my last theme is incentivizing the pursuit of scientific literacy. So we need to create things, create incentive for people to pursue scientific literacy and also communicate these benefits to them so that they feel motivated to actually, take on this skill set learning process. So my first suggestion for developing ways to get academic discourse in the hands of the public is through visual abstracts. Visual abstracts have been used, by some journals, but also by individuals trying to present their research on Twitter or, on their own personal mechanisms. But visual abstracts have a lot of good to be done in that they can help the topic be more easily digested by the person. Perhaps they'll go seek more information. And yeah, they've found researchers have found that when there is a visual abstract in a tweet, as opposed to just, plain text explaining research, people are actually more willing to engage with the actual article. And then for each of these points, I kind of have a way, I've tried to think of ways that we can keep this innovation going. So for this, we can maybe think about making interactive abstracts or video abstracts to further allow, the public to engage with that content. My other suggestion under this umbrella is what I'm calling the Wikipedia model. So Wikipedia, as I'm sure you know, has these very handy hyperlinks embedded in everything. And so it would be an interesting approach to start integrating these sorts of hyperlinks into academic literature so that as someone's reading, they can, hover over something and get a better understanding of, what that method is or what the limitations of it are, or, what this definition means and what people kind of are agreeing that this means. This would be very difficult to do, but it could be done. We could expand this whole system across the web, giving people the ability to easily look things up and have them be supported. There's also literature suggesting that when these hyperlinks are available, they actually help people understand better, because the hyperlink is usually to something, important in the literature. And so when you see this little blue line, you actually focus on it more and digest it more. And then my third idea under this umbrella, I'm calling the Reddit model. I have a bit of a Reddit addiction, and I really love forms like, this is the logo from Ask Science. So there's Ask Science, there's Explain It to Me Like I'm 5, Ask Me Anything. There's all these different subreddits that allow people to ask, experts their questions and have them answered directly. And there's no reason we shouldn't be able to scale that up so that the average person can submit their question for transhumanists, for thinkers, for whoever, they're interested in, have those questions, kind of combined and analyzed by artificial intelligence, and then sent to, the right expert, and then have them thoughtfully reply. I really think that it's important for people to get more engaged in this process so that they can hold like that whole accountability model, right? Telling the scientists what they want, what they need, what they don't understand. On to my second theme. So in terms of outreach, as you can imagine, making that visual abstract isn't easy for scientists especially, or for someone who doesn't have a background in graphic design. It would be intimidating if journals came out across the board and said that we all have to have a visual abstract. And so for that reason, and we're busy, researchers are busy too, right? And so for that reason, I think that it would be really important to start making kind of outreach teams for different departments, so that there are staff on hand to help, the scientists, the researchers, whoever, to develop these ways to communicate. The burden shouldn't just be on academics, because, or the scientists proper doing the lab work, because they might not have the want to do it or the skills to do it. And then kind of keeping in with that idea, we also need more interdisciplinary collaboration when it comes to producing media. So you need to, we need people who actually understand science to be able to vet scientific articles. I think there's definitely a lot of, sensationalization and a lot of taking things out of context. And there's generally not any scientific person around to actually say, you interpreted that study right, or, that's fair to advertise to the general population. And then I kind of think that maybe artificial intelligence or neural networks could eventually be used as a sort of peer review system for these different articles. I've included here on the left the Surgery 101 logo. That's Dr. White, who I think we've talked about in our class. he has a team, an interdisciplinary team that helps him put together all these different educational videos for surgery. And I think he would agree with me that it would not be possible by himself. You know, he wouldn't have the kind of creativity or the know-how to produce a lot of the content that they make. And then kind of continuing with this whole outreach and thinking about new ways to, you know, share research with people. I read a paper about, he talks about becoming a nerd of trust in your own social circle. So people, you know, often shy away from sharing their own research or sharing their own scientific opinions on their social media accounts. And this form of outreach isn't really, you know, favored among academics. Like if you write on your NSERC grant that, oh, I post on Facebook, like they don't care or they might not. But in actuality, like I think that is one of the best ways to reach people. You know, the people you have in your circles, they're the ones who are going to trust you a lot and they're going to respect your opinion. And so what I propose here is that, you know, granting agencies and academic institutions actually start taking that form of outreach more seriously, and that they support their staff in finding new ways to adapt and, you know, kind of integrate into this whole broader project. In terms of incentivizing pursuing scientific literacy, I found this course on Coursera. It's actually made here at the U of A. They have, I think, like 5,000 people who've taken it so far. But the principle kind of could be similar to first aid training. You know, you get your first aid training, you put it on your resume, and even if you're not going to use first aid training for that job, you know, specifically, it lets your employer know that you have a certain skill set and that you have the ability to, you know, problem solve in a certain way or what have you. And so if we adopted this sort of model for people who aren't necessarily in the sciences, we could help not only teach them and incentivize them to take on this project of learning, but also give employers, you know, some reassurance that their staff are ready to work with Excel and that they are ready to, you know, not get phished when they get an email or, you know, whatever. There's so many different applications. But to develop a good course and a consistent training module would require a lot of, you know, peer review, collaboration, and yeah, you could also use like Google Trends to kind of understand the needs of the public, to understand what scientific things they're not quite getting and what they want to know more about. And then we can also kind of revolutionize how we engage people on social media. So this logo on the left here is from the Google Science Fair, and it is an online competition. I don't know if they're running it this year because of COVID, but it's for teenagers, and it's basically like a grown-up science fair. And it challenges teens to engage with problem solving, innovate things, and there's no reason this couldn't be applied elsewhere on social media. You know, we can have, I like Instagram. That's my other social media of choice. You know, there's no reason you can't get your followers to come up with an idea and, you know, make little competitions, even if there's not an official prize. Or, you know, maybe you can collaborate with different institutions and have actual prizes for, you know, creative thinking or problem solving. Yeah. And then this one is kind of different. This is Tell Walter. I kind of went on a rabbit hole finding Walter, but Walter is a artificial intelligence that is used to detect logical fallacies in a text of writing. So if you, like, whoever made this came up with this in like the 90s, and he called it belief scan. And the way that he has it working is that you input your text, and then it'll ask you like a series of questions about what you meant and all this stuff. And it will ultimately tell you if it's likely that you've committed a logical fallacy. And so if you're not familiar with logical fallacies, there's a whole bunch of different flavors of fallacies, but it refers to an error in argumentation or an error in logic. And so if we took Walter and we gave him a social media account, perhaps he could help other people, begin recognizing their habits and begin, getting feedback on the kinds of arguments that they're making. So like when, like I actually downloaded this app, and this is what it looks like. It's still pretty, it's great though. But it'll actually explain to you like what the fallacy was, what, why it happens, blah, blah, blah. And we could use this to actually implement, change the interface of social media so that people can be held more accountable. There's obviously a lot of problems with this, as with like all the fact checking on Twitter, like there's a lot of controversy on, how much interference there should be. But if you even just think about, the automatic bots on Reddit that will tell you if you made a haiku or tell you if you, I don't know, there's all sorts of different silly bots, but maybe there could be a Walter bot that helps detect logical errors. And yeah, artificial intelligence has a lot of problem with understanding argumentation because a lot of it has to do with context. So if we did set up this sort of fallacy bot or a Walter social media account, it potentially, if we use the human feedback at the same time, we could help AI actually improve and learn how to detect these fallacies better in time. And those are my main points. I would love to hear what you guys think. This is a project I'm actually going to be pursuing, so I'd love to hear what you think is realistic and if you have any other ideas.
Taryn, thank you so much. How relevant to our current human situation overall? Because I think that if we gave the tools to every human to be able to objectively analyze information, we wouldn't be going down these fake news routes and all these things. People would be able to take the information and really be objective and see, well, this is likely true, or this is not, and then make better decisions, I believe. Mm-hmm. So if you are pursuing this and maybe implementing it in our societies, keep us posted by all means. I would like to share it with as much people as I can. I liked your approaches, the three of them, and I wonder if you have heard about biorender.com. Biorender is a scientific platform where you can easily make abstracts, graphical abstracts, and they have seminars, and they have a website that provides tools that are extremely easy to use and facilitate scientists that don't have the skills in Photoshop to actually come up with really good abstracts. So if you can look into that, maybe you can share it.
Yeah, thank you.
But thank you. This was wonderful.
Yeah, it's been fun thinking about it.
Yeah, no, I agree with what Eduardo said. I really liked your approach in the three kind of themes and how you structured everything, and you had different suggestions for each of them, and it was just really easy to follow along with. And your point, I think that stood out the most to me, was about what Eduardo was just talking about in terms of like rendering the graphics and whatnot. I liked how you said we need more interdisciplinary collaboration, because I think that's super important moving forward, regardless of like what industry or what job or career you have, because like being able to communicate information well through a graphic, like all the graphic designers know how to like build a like make a graphic so that people understand what it's saying, but they need to also get that information and know what is important from the researchers and from the scientists themselves. So it's really interesting to see you like put that forward, because for me, from the way that I see it, a lot of the times people in the more what is considered like creative arts are kind of undervalued, but they they deserve that kind of recognition, and what they do is important in that realm too. So I really appreciated that, and like the rest of your presentation too. And I like that you considered the political implications of like all of this, like everything that you talked about. So yeah, really great presentation. I really enjoyed it.
Thank you.
Yeah, really, really great presentation, Taryn. I just wanted to say, well, it's the first time that we really heard your voice, so it's really nice to finally meet you and see you
That
in the
too.
flesh.
So, this is different and exciting in the ratio of ideas from the student versus ideas from researching what's already been done. This has a lot of ideas from the student. And I mean, one intriguing thing is how satisfying it is to listen to and how few references there are, because it's not really conveying a lot of ideas from other people. It's really a kind of synthesis of a chaotic background of the way transhumanism is now, and then coming up with a strategy for fixing it and making sense of it. And that doesn't need a lot of references. It just needs good ideas and sort of a path forward and energetic pursuit of that path. So yeah, I find this really exciting.
Well, thank you.
Yeah. So, any other questions or comments? I think that, as Eduardo said, this would have lots of positive spin-offs, sort of unintended, positive unintended consequences, right? So like trying to make more sense of transhumanism, have it benefit society more, would also help us with a lot of other things, like fake news and conspiracy theories and so on. So yeah, anyway, it is in aggregate really an exciting thing to think about, and a breath of fresh air, which I think will have long-term benefits.
Taryn,
Okay, now
I have one question.
Yes.
Well, first
Yeah.
off, Taryn, this was a fantastic presentation. I think it's, it's something that I think we need to be talking about more in our society. And in your sort of, exploration into all of these topics, what is your thought on lawmakers and policymakers that are often making policies that are affecting, things that are out of their scope? Like they may not be academics in a certain field. They may not be healthcare professionals. They may not be understanding the depth of the scope of some of the issues. And so how do we ensure that the decisions that they're making are informed from an academic standpoint? You did mention sort of those courses, facilitating discourse. But for those sort of folks that are so busy, they don't have time to do a course for scientific literacy. So what are your thoughts on that?
Well, I assume that you've been watching the same COVID meetings that I have from our government. And it is a problem, right? The argument that has been made by a lot of people is whether or not scientists, like, our leaders are democratically elected, right? And so the problem is in allowing a scientist to call the shots exclusively. You know, they haven't been formally elected by the people. They're just more a figurehead. They're maybe more just an advisor. So I think it would be really interesting to get scientists into politics, have them actually, you know, be elected or selected in some democratic way, but actually have them have to have certain qualifications to even run for that position. It's a messy system, right? Like, to balance objectivity in science versus, you know, what the people want. If the people end up not wanting a good scientist, like, I don't know what we would do then. But yeah, definitely just integrating that relationship better.
So it's interesting to think about two scientists who are in politics. One is David Wood, who's the leader of the London Futurists, and he's getting more and more into politics. The other is Zoltan Istvan, and they're two different examples. David is a very reasonable guy, and I must admit he and I are pretty good friends. Zoltan Istvan began as a journalist and loves doing shocking things, you know, proposing something that you would just think no one could ever in their right mind propose that. So they're kind of a good and bad example of how scientists and science-trained individuals can end up in politics. And Zoltan ran for president in 2016 in the US and so on. Had this big bus that looked like a big hearse or coffin.
Yeah.
Yeah. But he's a physically very large person also. You sort of react, I think, naturally, instinctively, to just such a you know, physically large human in your presence. So
yeah, I don't think, like, scientists, maybe because they're kind of going for, like, they're scientists going for political office, but there could be more of like a companion system, right? Like, we don't necessarily need politics to look how it does today, and we could maybe create more infrastructure to have science, politics, but also politics is, do you know what I mean? Like, more of a secondary system, because we still do need, you know, certain leadership qualities, and, you know, we might not want like a scientist being president or what have you for whatever political reason, but to have more of a collaborative effort and make it more ingrained in the structure would be really, really good.
And I think there's been kind of a conceptual error of recommending poet leaders. And you can find many videos where that's the final end, and people say, wow, what a great idea. Like, we should send more poets to medical school, and then we'd have much better doctors and all this kind of thing. Send them into politics and so on. I know it's a romantic idea, but I think that is not such a good idea, and it hasn't really worked. I mean, there have been a few leaders who were actually, poets, philosophers, and that they haven't been like much better leaders than other people. But leaders who actually understand science, either directly or listen to the people who understand science around them, that's a much more promising idea than the idea of promoting poets or philosophers as leaders. So in the background is Ashley. She is here, right? She has a presentation to give. And
yeah, I'm here.
Yes, I think we should get to Ashley's presentation, because otherwise we'll be so fatigued that we won't be able to properly take it in. But anyway, Taryn, thank you very much for that. And we'll now go on to Ashley's presentation.
Sorry, my Zoom is not cooperating with me. Okay.
Yep, it's working.
Okay, so I apologize for being late. I had to work with my real placentas. So now I can talk about the artificial kind. So welcome, my name is Ashley Stokowski, and this semester I worked on a project titled The Background, Physiology, and Ethics of Artificial Placentas. So placentas are something that are obviously very important to me as I want to go into the field. And I wanted to look at what type of research has already been done. And Dr. Van Manen significantly influenced my paper to talk a little bit more about bioethics. So feel free to ask any questions throughout the way if you don't understand, as this topic really requires a lot more than 20 minutes to fully understand all the complexities, but this is my attempt to do so. So the process of fertilization involves an egg and a sperm joining together. This cell then divides and creates a blastocyst around day 5, which can implant into the uterus. So a blastocyst contains an outer layer called the trophoblast or the trophoectoderm, which is a pre-placental structure, and an inner cell mass that eventually will compose the fetus. So a placenta is a fluid-filled organ that develops within the uterus and is essential for facilitating the exchange of nutrients, hormone, gases, and many other things between the mother and the fetus. So to understand overall fetal development, I will explain some significant stages. So the first trimester begins at week 1 after fertilization, and it's where an embryo must go from being a single cell to multiple structures. The second trimester begins at week 12, where all major systems are now formed. And around week 22 is when a fetus is now viable to survive outside of the womb, but requires a lot of medical assistance. So a preterm infant is born generally between week 22 and week 37. So the third trimester starts at week 27 and reaches until term. The fetus is mostly just developing fat and has some further fine structured development. And then a full term is at week 40, where the fetus is fully developed and is ready to begin the process of birth. So to ask you guys a question, what do you think of when you hear or see the words artificial placenta?
I imagine like that movie Alien. Remember where Ripley, she had several clones of herself and they were floating in tanks like that, something like that, like a tank with a floating body or body-like structure.
Okay. All right, yeah. If anyone else, no? Okay. So what I think about when I hear the term artificial placenta is I think about the society in Aldous Huxley's Brave New World. So this book was actually first published in 1932 and looked at a society that used an artificial birthing process. So human eggs were fertilized with sperm in a test tube, and then the fetus was incubated until term. There was also a lot of other things that kind of added along the way and changed, but for this sense, it's very similar to what I think of. Although this isn't a real scenario yet, it's far from only being a science fiction concept. So there's three kind of main scenarios of an artificial placenta that I could think of, but there may be more. So the first is an artificial placenta made of placental stem cells. So these cells would be retrieved and differentiated into different structures and grown in a dish to replicate a normal placenta. So this likely takes about the same amount of time as a placenta normally takes to develop. And for proper development, that's at least 11 weeks. So this is also might be really hard to implement, as good enough physiological representations of a placenta are not ethically allowed. So the stem cell structure would have to be significantly similar to the normal placenta for ethics approval. So for these two reasons, I don't really discuss stem cell artificial placentas much further. A full-term device would either have to be an artificial uterine environment where the blastocyst could then implant, or we would have to separate the inner cell mass and put this into a small AP device that could mimic and expand with the growth of the embryo. So this process is very complicated and is likely a very far future concept. So the final and most actualized device would be used for preterm fetuses. So this device would replace the neonatal intensive care unit medical equipment that premature infants use and would further incubate them, providing nutrients in a fluid environment until complete development. So the full-term device, meaning blastocyst to birth or full term, would already have some development steps already established. So full-term artificial placentas would likely require in vitro fertilization. And this is a process that's already commonly used in humans. So in this process, sperm and eggs are retrieved from the future mother and fetus, or father. They're combined in a dish, and then the fertilized egg then develops for a few days and is implanted into the uterus. This scenario also kind of mimics the beginning of Brave New World, but a majority of the fetal development in this actually occurs in a normal uterine environment. So in full-term artificial development, this fertilized egg could then be implanted into an artificial uterus and develop similar to the normal process. So the potential timeline of artificial placentas is that the first research article containing the word artificial placenta was published in 1946, but it mostly discovered or discussed mechanical oxygenation, and it wasn't that close to what an actual artificial placenta would be. But this does mean that this idea has been around for a long time in the scientific community. So these actualizations of artificial placentas in humans for the future are complete estimates. This is just a guess of when I think that it could potentially exist. So in the next 100 years, potentially a preterm fetus incubation could be performed in humans, as there's many technological developments that have already been established. And in the next maybe 1,000 years, full-term artificial placentas could be developed. So the full-term artificial placenta is not really likely within the next 100 years, as there is so many advancements and research first needed to be performed. So the development mechanisms, protein regulation, gene regulation, nutrition, hormones, and many other concepts all need to be first understood for every single time period during placental growth for it to be replicated. So if we do this how we are doing it now, I don't know if this is ever going to happen. But something that could potentially speed up this process is that by using artificial intelligence to prioritize mechanisms or proteins. that this is what we should focus on first, and this is what is essential for these artificial placentas to actually exist. So the actual research that's already been performed there is a significant study in 1993 by Uno et al., where there was premature goat fetuses incubated in a fluid sac for about 20 days, and they survived for about a week outside of the system with ventilation help. Throughout the next 25 years, there was kind of some sporadic studies, but nothing too huge. But in 2017, Partridge et al. Added immature lambs to a fluid sac for about a month, where organ growth and maturation was observed. So to go into this study a little bit more, what they used is a pumpless oxygenator, which is attached to an artificial circulation device. So this device is then attached through thin tubing or cannulas that enter the lamb's umbilical arteries and veins. So the lamb was removed from the mother after an incision into her uterus, circulation was established, and then they are placed into a bio bag filled with an electrolyte fluid that mimics amniotic fluid. So amniotic fluid is significant as it provides protection, nutrients, and specifically allows lung pressures to be maintained for development. This amniotic fluid is then pumped through a system. So the umbilical cord is how the fetus receives nutrients from the mother and can be seen to work artificially, as you can clearly see the development of the lamb in these pictures from gestational day 111 to 135. So there's a clear increase in size, in hair, and overall development can be seen. So this process could likely be modified to happen in humans. So if a potential preterm birth was initiated, a C-section on the mother could be performed. The fetus is then connected to circulation and placed in a bio bag, and then could further develop until term. So to explain the importance that these devices could have, 15 million preterm infants are born a year, and 372,000 were born in the US in 2017, which is more than 1 in 10 births. So there's a huge, I guess, market to help preterm fetuses. So to expand on the premature lung development, immature lungs are a significant issue that many preterm infants face. So the alveoli
Thank you.
are a branch structure that helps facilitate gas exchange in the lungs.
But I'll try to present with my laptop. I hope it will work.
Okay, yeah,
It should work. I
yeah,
think so.
wonderful, great. Okay, thank you.
Okay.
Sorry about that, folks.
So the immature, so alveoli are a branch structure that help facilitate gas exchange in the lungs. And these are significantly underdeveloped in a premature fetus. So the first breath is often known to be one of the most difficult, as the lungs must switch between a fluid to an air-filled environment. They must properly open and they can't collapse. So if a fetus has to undergo this difficult process that all babies have to do, but they have underdeveloped alveoli, then it's an even harder struggle. So the artificial placenta avoids this issue by creating a fluid environment that maintains the pressures and the fluid-filled lungs to help them allow for further development. So as you can see, the NICU requires a lot of medical equipment. So there's a ventilator that helps the infant breathe, which requires often an endotracheal tube in the infant's throat. There's feeding tubes, oxygen monitors, electrocardiograms, blood pressure monitors, IVs, umbilical catheters, incubators for warmth, and many other things. So regardless of the cost of this equipment, it also puts a lot of physiological stress on the infant. So many of these procedures require direct contact and have to be placed inside. They're loud and it's hard to control the temperatures. So when you compare this to the artificial placenta, the fetus is really only attached to the system by its umbilical cord, which is a lot more physiologically equivalent. So the fetus is also maintained in the fluid environment that can block sounds and regulate the temperature. So to clarify, the intent of a preterm artificial placenta is not to extend the viability of a fetus outside of the womb, but to help with scenarios that would already require time spent in the NICU and to avoid this step altogether. So the hope is that the artificial placenta would allow the fetus to mature all the way to term, in that it can be birthed and can go home with its parents. So eventually better technology could lead to extending viability, but would first have to go through even more rigorous testing. So the development of artificial placenta brings many physiological benefits to preterm babies, but with these manipulations come a lot of ethical considerations as well. So we've already discussed the 4 bioethics principles in Dr. Van Manen's class, and these principles work as a framework for understanding and guiding many medical professionals' moral and ethical principles. So the first is autonomy, which involves respecting and supporting autonomous decisions and involves liberty and agency. Nonmaleficence avoids the causation of harm. Beneficence pertains to relieving, lessening, or preventing harm and providing benefits and balancing these benefits against the risks and costs. And justice is fairly distributing benefits, risks, and costs. So I will present the topics that I've already discussed in my paper, but I know there are many other ethical considerations that are required. And if you guys want to discuss this after as well, feel free, because it kind of just never ends. So autonomy can be split into 2 concepts, that the parents hold the fetus's agency, or the fetus itself at some point will have agency. So some people believe that an infant does not obtain autonomy, as infants are reliant on parents and they have complete control over the child's life decisions. So the other side mentions that even if an infant doesn't currently have autonomy, they will when they grow up. So in Canada, the parents' autonomy is respected, provided they make a reasonable choice and are not using their child for secondary gain. So with artificial placenta technology, the fetus is unable to make informed decisions, so the parents must decide if a preterm infant is to be added to the artificial placenta. When the infant grows up, they may feel that their autonomy was taken away from them or disagree with the parents' initial choice. So as the artificial placenta gives a choice of artificial placentas over the NICU, and a healthcare professional is responsible for the patient's autonomy and not the parents, there's many ethical dilemmas that may occur. So many of these concepts can also be applied to the full-term artificial placenta scenario, as people have even more controversial and divided opinions on if early embryos have autonomy. For non-maleficence, this procedure requires needle insertion and can cause immediate or permanent damage through complications. Non-maleficence can also indicate that not using AP technology when it's available could cause undue damage to the developing fetus, as the use of AP for preterm infants would generally be considered non-maleficent, as it decreases the physiological stressors or harms of that individual. It'll also help individuals who have a risk of pregnancy complications safely have a biological child. When AP is used for non-emergent patients or for full term, the intent is more complicated. It's not clear if a full term AP scenario would directly cause any harm to the fetus, but in the scenario where the inner cell mass may be separated, it could cause undue harm to the embryo, and that would not happen if it was left alone through the natural process of pregnancy. For beneficence, it can be understood through 3 different views. There's vitalism, sanctity of life, and instrumentalism. So the vitalism view indicates that all life is important, no matter the form or consequences. So vitalism viewers would likely use an artificial placenta in any scenario if it extended the life of the fetus. The sanctity of life viewpoints look at the worth of a life, but they also use distinctions between ending and prolonging it. So not extending a suffering person's life is allowed. So in this case, they would use an artificial placenta if it prolonged life in a positive manner, but may have issues not using it if a life would end through current medical equipment. So the instrumental view is based upon the requirement of life being of value, and it has to be good. So a good life can be prolonged and extended, and a life that is void of quality can be ended. So instrumental views are where the scenario becomes the most complicated, where an infant could be added to the artificial placenta to extend their life as long as the infant's quality of life could be preserved or improved upon to an acceptable level. The vitalism viewpoint kind of has an obvious and broadly accepted answer, as they'll always use it, but the instrumental view looks more at a case-by-case basis and is likely what healthcare professionals would have to use. So if a fetus were to undergo this AP procedure but would suffer excessively or would only prolong a bad quality of life, artificial placentas would likely not be used. So the use of artificial placentas in a way that promotes justice would mean it has to be available to all individuals. So this universality may not be physically possible, as every preterm infant would require a large amount of equipment and money. The best thing that I believe a healthcare provider could do is to create a triage list that's not influenced by money, status, race, or anything other than the fetus's requirement to survive. So this procedure would be very expensive, and currently IVF treatments are not covered by insurance. So kind of indicates that likely these more expensive procedures would also not be covered. So this then means that the costs come out of the parent's pocket and would be only available to those with money. So do you guys think that barriers to these technologies are a good thing?
I don't know. What do you think about overpopulation? Because that's another issue. We already are, in a way, beyond the capabilities of our planet to provide food. So bringing more babies in this way, is it fair for the planet more than for humans? I don't know. What does anybody else think?
I think this is more of weighing the advantages and disadvantages. Barriers can be solved once there is, critical move toward the advantages and minimizing the disadvantages. So I think it is a kind of rational thing.
So the cost will eventually come down. Like television was very expensive in the beginning and so on. So you can imagine that a lot of treatments which are only available to the rich in the beginning eventually get spread out to many more people, not necessarily everyone. So whether we're overpopulated or not is not easy to really figure out, particularly if we are populating other worlds beyond Earth. And if you look at it from an energy point of view, the amount of energy received from the sun is many-fold greater than what we would ever need. So, I mean, it depends upon what your metric is.
Can I also add that, while it would be expensive at first, there also would be a certain amount of risk in trying it out. So it'd be interesting to see, I'm not sure if a wealthy person right away would want to throw their baby in an artificial placenta. Do you know what I mean? They might have more hesitations and would rather go through, tried and true methods before just jumping on board with this. So it'd be interesting to see what demographic is used to kind of test the technology out.
So I will add that the Partridge et al. Study that used the incubated lambs they said that the technology, if it were to be used in humans, the first clinical applications they would use are the like 23 to 25 week old fetuses that technically can survive in the NICU and have, but the outcomes are like extremely poor because they're just so young. Like they're pretty much only halfway through their development. So that was kind of where that paper decided that the starting point might be, is the youngest kind of possible that they think would survive in it, but may not really survive outside of it, or at least have a good chance to survive. Yeah. So for a review, there's 3 different types of APs. There's stem cell, full term, and preterm. For the stem cell, it requires a lot of extensive knowledge and replication of a normal placenta. The full term is really far in the future, but could have potential through IVF and artificial intelligence. In preterm, the previous experiments have been replicated in animals and could help alleviate NICU issues. Lung development is really important in this process, and ethics, there's a lot of scenarios that would need to be analyzed first. So the real life implementation of artificial placenta technology may be more intricate and controversial, but advancements may soon rival Huxley's depiction in the near future. So it really is a brave new world of scientific research. Thank you very much for your attention.
Okay, yeah, well, there is something nice about the last presenter having chosen to be last. That wasn't really the case in previous years. And so the last presenter got a really raw deal in previous years, I think. But whereas today, yeah, I think we actually, we seem, you guys don't look completely worn out. So I think this will be reasonable. So what do you think? What questions do you have? Questions, discussion?
I have a question. Sorry, Eduardo, for jumping in. So I haven't heard a lot about risks of that technology. I believe, is it IF or NICO? I forgot. But I mean, what risks did they experience where they're growing that little lamb?
So one of the main things that they talked about was the kind of risk for contamination or for like bacteria to get into the process. And they had to use a lot of different materials to get the bio bag that they put the fetus in to be correct, because it ended up that some of them had kind of like, they would get bacteria in their lungs and it would cause issues. But eventually they kind of developed a process that was completely sterile, or as sterile as it could be. And that was kind of the main thing that they looked at for risks. There's obviously a few more with, you have to like cut open a mother and do this transfer. But I guess it's one of those things that like there is risk, but some of those risks are already kind of established as they're going to be a preterm birth. So the preterm ones, I think, have a lot more, I don't know if it's benefits, but it's like, this stuff is already going to happen. Like they're already coming out and they're already being born. So any risks that are already there are probably already existing without the help of the artificial placenta, where this is just kind of like a process that's trying to mimic what they're already doing.
I was thinking about the chances of blood clots, since they used like a artificial circulation system to provide the to feed the baby, or to just move the blood around. I believe there would be some sort of medications that should be essentially used to avoid, as you said, contamination, blood clots, maybe, some other stuff that could happen through this artificial process. So this is apply another rule in the ethics. It's not only the process of being an artificial placenta, but what would be adab on that, and in which a situation, how far could that go? Maybe if that's in normal condition, you will maybe little, you need a little, kind of medication to control the contamination and blood clots and that stuff. But if there is any higher risks get on, maybe there will be more adab medications or interventions. So I agree with you that the ethics of this topic is really complicated, and it would not be resolved easily, but it's a very good approach. I appreciate your topic today.
Thank you.
So one thing that has changed a lot in the last few years is just the human acceptability of this as a topic that they're willing to discuss. This was something that just seemed icky to most people like 10 years ago. And the whole idea of children developing outside the womb and so on. And it's kind of similar to in vitro fertilization. When it first began, was extremely controversial, and there are all sorts of ethical discussions about it and so on. So anyway, the world is changing. This is not as creepy for you guys as it would have been for students 10 years ago.
Hey, thank you, Ashley. That was really, really cool to see. And I didn't appreciate too much where it could be applied when you asked the justice question. But then after you explained that it could be used in the NICU already, and it could be less invasive for the baby, I see a lot of benefit. But as Hadith said, maybe we will need to add more special antibiotics and other things to assist the baby's development without bacteria or any other side effect. And we don't know if that will have long-term effects, right, in the babies. But for sure, I think it's something that we may see in our lifetime. So that's exciting. Thank you.
Okay, further discussion? I want to thank you for staying so late, above and beyond the call of duty to stay until 4:25. Yeah, that's something. But anyway, four great presentations. I'm going to look forward to the editing that I'll be doing tonight and so on. Hopefully I can get them up there soon. So anyway, I've enjoyed running the course, teaching you guys in the course, and thank you. Please encourage your friends. I would point out, I'm not looking for you to push people who are wrong for the course to take it, right? I really want people who are right for the course, right? So if you're able to coerce somebody into taking the course, that's not good. But if you're able to actually get them excited about the course, and if they are part of that small cadre of brave, courageous, forward-looking students, yeah. So I welcome your help in finding the next groups of students for 2021. And I already have sort of a positive feeling that that will turn out well. So anyway, thank you for everything. I'll be getting your grades to you. You know, that's a two-step process. So somebody has to approve my grades, right? So it's not completely up to me, but it usually turns out pretty well. That person and I have been dealing with grading in this course now for 9 years, so I sort of know what she wants. So yeah. Anyway, I will try to complete that as soon as possible. I wish you well. I'd be happy to stay in contact with any of you who wish that. As I pointed out before, to some students, and this is fine, this is just another course, you know. To other students, it's life-changing, and you know, their whole life is altered by the course, and it's never the same again. And they keep doing stuff with the course then for years and years after. So whichever of those categories you fit in, that's fine. But I would be happy to have future interaction with you. And now you're probably getting so tired of being on this Zoom call. Yeah, it's been almost 2.5 hours, if you can imagine it. So I think I will let you go. But anyway, I wish you well, and thanks for being part of the course.
Thank you. Merry Christmas.
Same to you.
Thank you very much. Yeah,
Thank you
very
so
kind.
much.
Thank you.
Okay, bye-bye.
Bye.